お待たせしました。遅れてしまいます。申し訳ありません。はい。では、これからこのセッション始めてまいりたいと思います。最初は、今日、2回目の基調講演ということで、クリス・サンギン先生、エディンバラ大学のクリス・サンギン先生に基調講演をお願いいたします。テーマはスタックということで、ご存知の方もそうでない方もいらっしゃるかもしれません。個人的にはずっともう5年、10年ぐらい、10年までいかないんですかね。使っておりまして、非常に大好きなシステム、非常に強力なシステムで、もともと数学のシステムなんですけれども、ぜひ数学以外の分野にですね、幅広く使っていただきたいなというふうに思っています。で、昨年スタックのカンファレンス、ダラって、スタックカンファレンスがあった時にお会いしまして、今回のこのムードのテーマが、いろんな分野でのムードの活用ということで、スタック、まさにテーマ、一番良いテーマの一つではないかなというふうに思いまして、クリス先生をこちらにご招待して、心よくお聞き受けいただいたということになります。はい、私も非常に楽しみにしておりますので、皆さんもぜひですね、スタック使っていただけるようになると嬉しい。Let's begin our second keynote presentations today. The topic is STACK. So some of you here may know the name, or others may not. But I personally really like the plugin. This is originally developed as a plugin or software for automatic mathematics questions. And I really love it. And I used the plugin, the system for maybe more than 5 years. And last year, I participated in a STACK conference held in Durham, and where I met Professor Chris Sangwin of the University of Edinburgh. Chris is the professor of mathematics education, and he's well known as the developer, founder of the STACK system. So I hope you all here will also like the system, and I personally really like the software, and I really look forward to the presentation. Yes. So let's begin. Please welcome Professor Chris Sangwin.
So thank you very much for this very kind introduction. Thank you for inviting me to this conference. I must apologize that I only speak English, so I'm very sorry about that. If you have any questions, please just interrupt. This is University of Edinburgh. I've been in Edinburgh for 10 years. I'm going to talk about STACK. I appreciate this is a general audience. STACK was designed for mathematics, so I will just make sure everybody understands what the plugin does. I will describe how we use the plugin. I will describe where we are now. And then I'm going to talk about technology and education in general to try and answer this question: what will AI change? What will we do about AI? And so I will talk about future tools, developing STACK and developing other technology, but also I will talk a little bit about future goals. Conferences like this, a Moodle Moot, is always about the tool, but the tool is there to do a job. So we should think about the job that we're trying to do with the tool. Okay. And this is the real key educational message. And it's an idea, it's a sentiment that comes from a colleague from Nottingham University, Hugh Burkhardt. And he said, we want tests worth teaching to. So we should have tests that are really valuable in some way. And that's an idea that's really stuck with me. And I hope to illustrate that in the course of this talk. So what is STACK? STACK is a question type for mathematics. From the Moodle community's perspective, it is a plug-in question type for the Moodle quiz. Okay? So my contribution to the Moodle community is a plug-in for the quiz. Right. And the idea is that we generate random questions. So every student has a random question. The student's answer contains mathematics. So they type in an equation. The real goal is not to have multiple choice questions. Now, multiple choice questions are very valuable. Multiple choice questions definitely have a place, but I really want my student to give me an answer with some genuine content. So the whole purpose of this is that really the answers are mathematical. And then what we do is we check the properties. So in mathematics, sometimes you can write equivalent expressions in different ways. And the system understands that, and it's up to the teacher to decide when an answer is correct and what is relevant and what matters in this question, okay? So once the system has automatically checked the student's answer, then we have outcomes. So formative, summative, evaluative. Those are the purposes. So formative is usually text to help the student improve their understanding, improve their performance next time. So summative is usually a numerical mark or a score, so you get a mark. And then the last one, evaluative, is data. So I look at all the students in my class and I create data. Okay, so STACK creates all three outcomes. The Moodle quiz decides what happens to those outcomes. So the Moodle quiz settings, you can turn off the marks, score. You don't necessarily have the feedback, right? So there's lots of settings. And because my plugin is part of the quiz, when the student sees the feedback, if they see the feedback, what happens to the scores, how many attempts, and so on, that is all part of the quiz, right? Does that make sense? So how many people use the Moodle quiz? Okay. How many people have never seen the Moodle quiz? Okay, great. Okay, that makes my life much easier. Right. And underneath this, STACK uses computer algebra, which is software which really understands the meaning of mathematics and does computation. So it's like a calculator, but it works with algebra, not just numbers. So that software has been developed for many decades, 30, 40 years, and we're using that software on the server to do the mathematical work. So just as yesterday, the presentation showed us how to connect Moodle to a particular AI system. We are connecting Moodle to Maxima in almost exactly the same kind of way for a similar reason. And interestingly, last century, people described computer algebra systems as an early form of artificial intelligence, right? So, okay, if you look in the very old literature, if you can get a computer to do mathematics, it must be intelligent, right? So, okay. Anyway. So let me just show you. So we have, oh, okay. That was probably a mistake. Okay, that's great. That's working. In the interest of time, I have logged into Moodle. I have chosen my course. My course has a quiz. I started the quiz, okay? So we're all ready to go. And what you can see here is my question type. So my plugin is this question type here. If you understand mathematics, this is a very boring question, deliberately. If you don't understand mathematics, it really doesn't matter, right? So the idea is the student must type in some kind of mathematics. I will get this wrong. Again, it really doesn't matter. Let's do that. So the system understands the mathematics. This is a whole talk in itself, how we can type in mathematics. But anyway, there it is. And then this quiz is in adaptive mode. So there is immediate feedback. That is a choice in the quiz. So for this talk, we get immediate feedback, and I got this wrong. The only real message here is that the system has taken my answer. The system has performed a calculation, some calculus calculation, an advanced calculation, and then it has decided that my answer is not correct, and it has used that calculation to make the feedback. So the calculation really is part of the feedback, and that's designed to help the student improve their performance on the task. Now here they can try again. In an exam, they can't try again. That's all part of the quiz settings, okay? So does that make sense what we're doing? Yeah. So now the rest is just detail. How many features, etc., and so on, okay? Right, so I'll just show you one or two more example questions. Not this one, not this one. I'll just show this one. So so a number of things to notice. First, we can have multiple inputs, right? So there's more than one thing for the student to complete. And of course, we can have multiple choice as well. Multiple choice has its value, right? But the real idea is that we have some mathematics. Give an example of an even function. 4 times x cubed is wrong. Oh, that's even wronger. So again, here the system is really doing some calculation to decide if the answer is correct, right? Okay. So that's the demonstration. I could demonstrate this all day, but it doesn't really matter. We have a whole community website. Thank you for mentioning the STACK conference. In parallel to the Moodle moots and the Moodle conferences, we have our own meetings and conferences. There's quite a big group of users now. So this year, we already had a meeting in Spain. We have a meeting in Trieste in Italy. We have the international conference will be in Nairobi in Kenya in July. So please come along or encourage your mathematical colleagues to come along. It's a big and growing community, and the community site is here. Okay, I'm really sorry Stack is difficult to install for those administrators. It's precisely the problem of having to use this extra software. And I'm very sorry that Stack questions are so difficult to write. So I started Stack in 2002, and then I joined Moodle later. I had a previous software. I think when I was younger and ignorant and enthusiastic, I underestimated how difficult automatic assessment is, right? When you really try to encode and you really try to give this automatic feedback, you have to understand what the student might do. You have to understand how to help the student, right? I've tried to make this as simple as possible, but the basic problem is difficult, right? So it's partly the software, partly just the problem. So sorry for that. Stack is not only useful for mathematics, Okay. We also, inside the stack question type, have lots of other kinds of interaction. So recently we developed a drag and drop question. So I'm not going to demonstrate that live, but you drag the blocks here over here and create an order. Now, I was a little bit skeptical about these kinds of questions. I really wasn't convinced this was useful, but actually the students do not find these easy. The students find these very difficult and they have real value. So this is nothing to do with mathematics. The advantage of using STACK is that inside STACK, we have an algorithm which will take the student's answer and it will measure the distance to the closest correct answer the teacher gave. So the teacher can give more than one correct answer. Often there's more than one, right? So the system will decide which is the closest answer, and it will automatically tell the student what they need to do to change their answer. So swap these two, or move this one out and move this one in, right? It's only having the full computer algebra that makes it easy to write that feedback. If you wanted to write that feedback in PHP, it would be a really difficult thing. But because we have this full mathematical engine anyway, creating this feedback was maybe 5 or 6 lines of elegant mathematics, right? So there's real advantages to every subject to having this sophistication. So we have these really useful drag and drop question types. This is a mathematical example, but you could do this with other kinds of, in other subjects, I hope. So why did I build Stack? I really think assessment is the most important part of education. As simple as that. I'm giving a talk, I give lectures. I write books, I write notes. There are other things I do as a teacher. But really, I think the assessment is the most important part. And so that's why I wanted an assessment system. Okay. So how do we use Stack? We have informal practice. We have weekly tests. Stack is being used for exams more and more. In Finland, all the school exams are now digital. They have been completely digital since 2019. I know other exam systems are moving all their exams to be digital, and Stack is being used much more widely for exams. The one example I want to show is what we call putting the book inside the quiz. So I'll come back to that. And then lastly, we use Stack outside Moodle. So it started outside Moodle. One of the best decisions was working in the Moodle community. And now we have also Stack outside Moodle. Colleagues in Germany did the work to take the plugin and create a standalone version because they needed it for their exam system. And if you're using software in an exam system, you probably should use the software should. I chose that word carefully. I hope that's translated correctly. You should use the same software for the learning. So if you use something for the exam, you should use it for learning, right? I mean, it's only fair. So they wanted the same question, the same interface, everything. Right. So sorry, this is slightly blocked by the Zoom, but never mind. In 1984, Bloom taxonomy, so the educator, he talked about learning for mastery, and he wanted to compare personal tuition. So that's one teacher, one student, right? Really personal teaching. He wanted to compare personal tuition with the classroom. And he discovered that a personal tutor is 2 standard deviations better, right? So this is statistics. So one standard, this is a normal distribution of marks. So 1 standard deviation is about 1/3 of the group. 2 standard deviations is a lot, right? 2 standard deviations is a huge difference. Okay, so we can't have a personal tutor. So he invented learning for mastery, where students have regular tests. They really have to score 90%, and if they don't, they repeat the test. So nobody is left behind, but people take different amounts of time. So it's not very practical in a classroom, but that is now practical with online, right? So we created a course, Fundamentals of Algebra and Calculus. We ran this in Edinburgh. It's a 20 credit university course, so that's 1/6 of the year. So it's a big course. We started in 2018, which was lucky because teaching was disrupted in 2020. We were ready. It was fully online, and the idea was to put the book inside the quiz, right? So normally you have a lecture and you have some notes and then you have a quiz. But this is completely the other way around. The quiz was the complete organizational structure for the course. If only we had a technical expert. Thank you.
How do I make that part as clear as
That'll go. All right. I'm going to break it again and go back to this. I will just show you 1 week of our really what I mean by this putting the book inside the quiz. Okay. That one. So we made 1 week freely available so everybody could see it. So this really is the whole course. So every week the students come and work online, and you'll see that they have a getting started quiz, and then they have 4 content quizzes, then they have a practice quiz and a final test. So everything is in the quiz, continue the last preview. And so we have some information. Well, of course, we have some information to read, and then we have some questions about what they've just read. Right? But the quiz is the organizing structure, and everything is inside the quiz. And somewhere, I think, we have some small video clips. Yeah, so this is the Moodle description item. So all the content is the Moodle description item. And of course, you can embed videos in that. So that's how we did this, right? So students can do this at their own speed. They can watch the videos. It was very interesting when we changed teaching in 2020 online. Lots of colleagues tried to record a 1-hour lecture because that's what we always did. But we realized very quickly it's much better to have short video clips online. We were already doing that, right? 1 take, make the video clip, it's done. Then no editing. Yeah, much more efficient, much better experience, and then the students can actually answer questions, all sorts of things. Okay, so that was the idea. The pass mark at the University of Edinburgh is 40%. Okay, so normally the pass mark is 40%. So this is a cultural decision, right? So as a teacher, you can adjust the difficulty of the material. And so normally, University of Edinburgh, the pass mark is 40%. Right. Okay. For this course is completely different. It's a mastery course. So every week, the student has to demonstrate mastery of the material that week. And the final grade is that you have mastered means 80% on the final test, and mastered means you have to get 8 of the 10 weeks mastered, right? So this is a much higher standard than we would typically expect. And so the material, okay, by design, does not have quite as much really challenging material. Right? So there's a design here. Right? That was the idea. So how did we evaluate this course? We have a diagnostic test which we used in Edinburgh for many years. This is just a test which all the students take when they arrive in Edinburgh. So week 1, they sit this test, and that just gives us some information about the students. So of course, Edinburgh is a major world university. About 1/3 of our undergraduates are from China. Right, so we have a large group with very different backgrounds, so we want to know what they can do, right? So we always do this test. So for the students not taking this test, to evaluate this course, they take the test as normal, and then 3 months later at Christmas, everybody takes the test a second time, right? So for the students not taking this course, they gained 2%, so they really didn't change. For the students taking this course, they were significantly weaker at the beginning. That was by design. We selected the students who didn't do very well on the entry test to take this mastery course. The purpose of the mastery course is to help them reach the standard we really want. Okay? And then at the end of the course, they really have gained. So we have evidence that this mastery approach is really working. Okay? But it's quite different from traditional university teaching, which is in a mathematics department. Yes, that's still chalk. It's very traditional. That's the way it is. Okay, so outside Moodle, I've talked about exam systems. Colleagues in Kenya, the students all have a mobile phone. They have a smartphone. So they've really leapfrogged. They've jumped to smartphones. And so they wanted open textbooks. This is quite funny. Originally, they said, no, we don't want any tracking of data. We just want a simple open textbook, nothing as complicated as Moodle. I guarantee in 2 years' time, they'll be back with Moodle saying, oh, but I want to know what my students are doing. So they will come back. They just a matter of time. But for now, they're using this outside Moodle version, and we have completely open textbooks. The biggest single challenge for the STACK community is sharing questions, right? So as you saw from this course, we have 4 lectures, STACK questions in every lecture. We have a practice quiz. We have an assessed quiz. There's a final exam as well. So that one course has over 1,000 STACK questions. And we have to keep this organized. It's an absolute nightmare. It's really difficult to keep your electronic office tidy, right? It's just difficult. There's no criticism of Moodle here, right? Just difficult. Also, we have lots of colleagues using similar or the same questions in different courses at the same university or at different universities. So we have developed a new plugin for Moodle, which is quite new. And it is, I don't want that one, it's this one. For software development, have software called version control, so Git. So this software is designed to allow software developers to collaborate. So typically, I will be writing part of the software, you will be writing a different part of the software, and we have to merge those changes together into one final piece of software, okay? And version control already solved this problem of collaboration. So we've done exactly the same thing here. We're not reinventing this process, but we have connected the Moodle question bank on your Moodle server directly to a version control, Git, on your local PC, right? So there really is now benefit. Let's say we're sharing questions, you take my questions, you improve some of the questions, I can get those changes back. I can review them, I can then put them in the official version and share them again. So if anyone else is worrying about how to share materials like this, then this is our solution to that problem, okay? So please don't reinvent that. At least talk to us. So just to give you an idea of the scale of the problem, we come back to home. So I always have a Scratch course. This is just a play area for me. Question bank. Create new question. And I want a stack question. So as a developer, sometimes you feel like you're fighting against the enemy. Sorry, Moodle. So we had to put this link here. There was nowhere else to put it. So we also have a question library. And the plugin always comes with about 4,000 questions already. So these are battle tested. They're reliable. They've been used. They have random versions, full work solutions. Helm was a very large project involving about 20 universities in England, ran from 2002 to 2004. They created a complete engineering textbook. So in paper, it would be about this thick. So probably 300 or 400 pages, right? These materials are still used. During the pandemic, we got release of the copyright to convert them to stack questions. So we now have 2/3 of Helm in stack. Everybody has these. So if we just go down to something like the chain rule, right? So this is a quiz. So you can choose a question and you can review the question, you can import the question, or somewhere in here, there is a JSON file. So if I import the JSON file and go back to the course, I've now got the whole quiz, right? I don't think individual questions are a particularly useful thing to share. Actually, it's the problem sheet. The quiz is the useful thing to share. So we're sharing at that level. But to maintain that, we are connecting with version control. Okay, so that's the idea, right? That's probably a separate talk, but if anyone is interested in that, please let me know. There are lots of big projects. A colleague in Europe has a grant for 4 million euros to improve question banks, to help people find the questions and choose the questions. And it's a problem, right? Okay. Yeah. Right. So AI and Stack. Well, there's lots of things. I'm really excited. I'm excited about technology. We are already translating questions. We had great success. Another project in Germany produced university-level physics courses, whole courses, and we used DeepL to translate the materials from German into English and French so that colleagues in Africa could use them. So these colleagues wanted those questions. So automatic translation of questions works very well. And every teacher will read the questions through before they use them. So a native speaker will always proofread the questions. Mathematical language is very simple. It's very predictable. It is exactly the kind of language which artificial intelligence is most reliable at translating, right? So that's great. Authoring questions, colleagues in Spain already have a little button to help author questions with AI. I'm not going to demonstrate that. For mathematical writing, for algebra, reading in handwriting is very reliable. Okay, so that's no problem. I think the more interesting thing is suggesting questions for teachers, right? The teacher says, I want to teach this subject. What questions should I ask? So AI is already helping us with that. Okay, so that's already happening. I know AI will help with feedback. Ultimately, we will use AI to assess students' work. More ambitious projects are to create a model of a student. So we look at the student's data and we create a model of where that student is, and that will suggest the next question. That's the point here. The problem is AI assessment is not clear. Nobody knows what's happening, right? You say to the AI, is this correct? And the AI says yes or no. Well, who knows? Now, for mathematics, we have definite criteria. We know what we're looking for, so that's not really acceptable, right? STACK has this clear assessment algorithm, but it's difficult to author. So the approach that we're taking is that the AI will write the STACK question, and then the STACK question will assess the student. And that way we really know what is going on. So when the student says, why did I get this mark? We can say, look, this is exactly what happened. This is the criteria. It's completely clear. So we get the benefit of both. We can write questions more easily, but we don't lose the really valuable clarity. Okay. So I want to spend the rest of the time talking a little bit about how technology gets introduced. Because in mathematics, we've had lots of technology already. So I know artificial intelligence is very disruptive for other disciplines. People are very worried about this. But in mathematics, we had electronic calculators. We had all sorts of things that changed mathematics education. And when electronic calculators arrived at the end of last century, Hanisch is an Austrian educator. And he suggested that there are always 4 stages, okay? And the first stage is ignore. Nothing is going to happen. It doesn't affect me. I'm going to ignore it, okay? So ignore also includes, I can tell if they're using artificial intelligence. I can tell if they're cheating. You're still ignoring it, all right? That's stage 1. Stage 2 is forbid, okay? Don't use it, just forbid it, right? Don't use it. The third stage is accept it, but unhappily, right? Reluctantly accept, right? Oh, well, okay, I suppose you might. And then the last stage is require. Okay, so ignore, forbid, accept, require. Now, require of course, doesn't mean you force the student to use the technology. That's not what I mean. It means that you write the assessments expecting that they will have the technology available, they know how to use the technology, and the technology will help. So this was a problem with calculators, because in the past, that was the whole point of the exercise. Can you do the calculation? Well, then you just type it into the calculator, right? So you have to change the assessments a little bit, right? So those are the 4 stages. Now, I don't think anybody is at the ignore stage anymore, right? I mean, I think most people at the reluctantly accept. I think that personally, the 2 defensible positions are forbid and require. And we see that in school mathematics exams. Most countries, UK, have one exam paper which is calculator free, so that's forbid, and they have another paper with a calculator which is require. So both those positions are sensible. Forbid. What can the student do for themselves? That's really the question. So let's look at this exercise book. This is a 10-year-old child from 1858. Okay. So I have this is one page. Every page looks the same. This is beautiful handwriting. This is the word if, IF, right? This is just the most beautiful handwriting. If 30.5 pounds of tobacco costs £3, 12 shillings, 5 1/4 pence, what will £1 cost? So we didn't have decimal money. We had an old money, right? Anyway. So he's doing long division. So what is he learning? Right? Sorry, my slides are, the translation is blocking the slides. Okay. So what is he learning? Is he learning handwriting? Is he learning long division? Is he learning accountancy communication? Right? What is he learning? Okay. And why is he doing this? Well, and do we still need to do it? So I know for the humanities, talking to colleagues, the only time the students write is in the exam room, right? Because they're not allowed to use a computer in the exam room, so they have to pick up a pen. So professional people don't write letters on paper anymore with a pen. Okay. A computer was a profession, right? 100 years ago, you would employ somebody as a computer. They would spend all day doing long division. We don't do that anymore. Yeah. So forbid is all very well, but we should be very careful what we continue to expect students to do. Charles Babbage invented the computer. So this is one of his mechanical computers from 1837. Okay. Does anybody know why Charles Babbage invented this computer? What problem was he solving? Yeah. Sorry, I can't hear.
The accountancy.
Accountancy, sorry, yeah, thank you. My hearing is okay. Accountancy. No, he wasn't solving accountancy. He actually wanted to calculate logarithm tables, right? He wanted to create tables of numbers because before computers, a calculator would use these numbers to help perform a calculation. So this is an example of where new technology looks backwards. He was solving an old problem. Nowhere in Babbage's writing does he say everyone will have their own computer. Right. Nowhere. He just wanted to print tables of numbers. That was it. Yeah. And that always happens with technology. The new technology arrives and we use it to solve the old problem. It's perfectly natural. So for the mathematicians, another example is LaTeX. So LaTeX is a typesetting system for mathematics. I used it to create these slides because that's what I do. LaTeX was first used in 1989. Its software is still being used. But what problem was Donald Knuth solving when he wrote the software? He wanted to print books on paper. So LaTeX is a typesetting system. He doesn't encode any meaning. He just places boxes to print books. Yeah. So not even resizing the text or HTML or anything like that, right? So he's using the software to solve the previous problem. And I think that always happens with technology. It's just natural. I'm doing the same, right? So I'm using AI to write stack questions. So maybe I'm doing exactly the same. That's a very real danger. Anyway, so require. Well, if we require the technology, what is there left for the students to do? That's the real question. And I think for applied mathematics, that's probably reasonably easy. We have to identify the problem. We still need to check the answers. We need to make sense. We have a real world problem, okay? So the human has the problem and they have to interpret the solution and they have to explaining to the AI what you're trying to solve is still a skill, right? I still think of communicating with an artificial intelligence is just like writing a computer program in a very high level language. I remember programming in assembly language, and then you got like C and then some other better languages. Now we just have an AI language. But the fundamental problem is a human, I have to articulate what problem am I solving and does this solve it? So for the applied mathematicians and the statisticians, I think that's still okay. But for the pure mathematicians, let's imagine the AI can solve every maths problem. And it's not far off for school maths problems. You take a photograph and it gives you the answer, and it's normally correct now, right? I think the answer to that is culture, right? Engaging in culture. So this is a very famous problem. I'm sorry it's a little bit long. A farmer with a wolf, a goat, and a cabbage must cross the river by a boat. the boat can only carry the farmer and one single item. If left together, the wolf will eat the goat, or the goat will eat the cabbage. Okay? So the farmer must help them all cross the river without anything being eaten. Yeah? Okay. Has anyone seen this problem before? Hands up. Yeah. Okay. This problem is so famous, it has its own Wikipedia page. Where is it? I had it somewhere. Yeah. This problem has its own Wikipedia page, right? There's a whole Wikipedia page about this problem. It's a long page. So it turns out that mathematical problems have a history. People have been solving the same problems, in this case, for a long time. Alukin of York was a monk in York, and he wrote a very famous book, Problems to Sharpen the Youth. It was published in 790, and lots of those problems have been used ever since. The goat and the cabbage and the fox is one of those problems. Every generation solves that problem, right? I don't think that's going to change. I really don't think that's going to change. Of course, they can look up the answer, but why would you look up the answer? Yeah. So I think what's left is magic and surprise. I think humans are very good at spotting patterns. Patterns lead to mathematical theorems. There's something about beauty and simplicity, deciding if something is important, being a human participant. Now that's going to be difficult to sell to some students, right? I am a maths teacher. Not everyone who arrives in my class is enthusiastic about the subject. Right? But that's somehow the answer to artificial intelligence, I think. We might need to change what we teach, though. So I just want to give you, if I have time, I just want to give you one example of what I mean by tests worth teaching to, and an example of these things. And it's to do with the area of a triangle. So I hope that's mathematics that everybody here has seen. Right, so what is the area of a triangle? The area of the triangle is half the length of the base multiplied by the height, okay? Half base times height, yeah? So a few years ago, I discovered this crazy paper that has 122 different formulae for the area of a triangle. So you have to wait for number 38 to get to half base times height, right? Yeah, so this person collected together, I don't know why, anyway, there it is. And if you keep looking at the list, you see this formula, S times R. So the area of a triangle is S times R. So no half there, right? So what does that mean? So S is the half of the length of the circumference. So if you measure the length of the perimeter of the triangle and divide it by 2, that's S, the semi-perimeter. Okay. And R is the radius of the largest circle inside the triangle, right? Crazy, right? Okay. And so this is why the area is S times R. I'm going to risk moving this. Okay. Yeah. Just look at the picture. Yeah. Oh, it's beautiful, isn't it? It's surprising. It's interesting. Okay, that's exactly what I mean. Pictures like this have been used for thousands of years. They're not going to go out of fashion. People enjoy them. It's important. It's interesting. But can we go further? So let's do the same thing with a square. Draw the largest circle inside a square. Measure the length of the perimeter. The area of a square is R times S. Take a hexagon. take the largest circle inside a hexagon, measure the length of the perimeter. The area of the hexagon is S times R. Okay, let's take a circle. So the circumference of a circle is 2 pi r. So S is pi r is r. Easy one. So the area of a circle is pi r squared, which is S times r. Right? So for what shapes is the area S times r? Yeah. So crafting sequences of problems that start with something simple, start with something familiar, and end with a surprise, and we have collected together. This really, for me, is the heart of pure mathematics. And engaging in pure mathematics is engaging with sequences of problems like this, right? And there are lots of examples at every level. I chose something here which is just school geometry, but really at every level. So this isn't just boring practice of routine stuff, right? As a teacher, we have to craft interesting experiences. So what does artificial intelligence mean? Yeah, we will create better tools. I love creating tools, but tools do jobs, right? Let's have a tool to do some work. And I think we need better tests as well. So that's my answer. We need tests worth teaching to. Thank you.
どうもありがとうございました。Thank you very much, Professor Chris Sangwin. ちょっと時間がちょうど、3 minutes か。Thank you. さあ、じゃあ3分ほど時間が取れるということですので、ぜひ、ご質問などある方、お願いしたいと思います。So we have 3 minutes for questions.
Yeah, I have a very simple, easy question. Why is it called STACK?
So that's an acronym, a system for teaching and assessment with a computer algebra kernel. It was such a bad decision because it's a very common English word, and so nobody can find it. So Moodle was a much better choice than Stack. So any young people who are creating a project, don't do the same as I did. It's a mistake.
ありがとうございます。その他、こんなことで、1問ぐらい受けていきます。
So those courses, those courses that you were showing a bit earlier, the one was KAC, right? KAC? Are they available as part of the stack deployment and or are they on GitHub or something?
The Fundamentals of Algebra and Calculus course is one of the University of Edinburgh courses. So that's not available. Well, come to Edinburgh. Send your students to Edinburgh. Now, universities, so we give a lot away, but we also have to protect our own courses, right? There's no contradiction in that.
Just as a follow-up then, also the demo questions, do you have, are there questions in there now for, say, the new JSX graph features? And
Yeah.
things like that as well?
Yeah.
Oh, and
So the Stack library has lots of different purposes. The Helm material, which I showed you, is a comprehensive materials for engineering maths. But we also have templates and examples. I don't really want to have a little paperclip that pops up and says, you seem to be writing a JSX graph question. Would you like some help with that? Right? We don't want to go back to that, but we do need templates and examples. So there are lots of those in the library as well.
Yeah. So just to give a little context, the reason why I, an English teacher, am asking for it is because we actually, at AUMS, we're using the stack question type as a way of immersion English into the realm of mathematics so that our students will be prepared to use mathematics in the English language as well. So that's why an English teacher can do it.
Okay. Yeah, thanks for your interest. Yeah.
Question?
To follow up Adams, if we have a demonstration set of stack questions, can we share them on the Moodle Association of Japan showcase where we share courses?
I think that's a question for you, perhaps.
Yeah.
I think, or what should I, technically, what would it require? First, we have to install Stack on our sharing server.
Yeah.
And then
Yes.
we can do it.
Yeah.
Okay, so if there's anyone who's interested in Stack questions, we'll try to get some example on the showcase server.
So let's talk about that offline. In any case, we can put the Japanese language pack on our own demonstration server, which already exists, and we can share them somewhere. So there will be a solution to that problem.
Thank you.
今日はもうありがとうございます。時間になりましたので、一応講演を終わりたいと思います。Okay, so thank you so much. Okay, so let's thank the speaker again.